Ayisha will continue.
So hi guys, this is Ayisha and that's Dheeraj there. Our topic was gesture based, gesture recognition using IoT devices. So the next one, please. Yeah, a gesture is the movement of any part of the body to convey an idea or a message. Here, gesture we focus only on hand gestures, and yeah, continue. Besides recognizing these gestures, our aim today was to develop a home automation system based on these gestures. So, keeping that in mind, we considered these three methods of gesture capturing. First was pose estimation using cameras. This is a well established method, but considering the home automation application, we have a problem with placement of cameras. If we were to place a camera that covers only a specific angle, it would be an inconvenience for us to go and perform the gestures in front of the camera. And the other one, obviously, we cannot have a camera that supervises all our actions throughout our home. So we decided not to use that. And we also found another hand pose estimation method using IR tracking, where um, we'll have to do our gestures in the field of IR projection. Again, that would be an inconvenience. So finally came down to the accelerometer and gyroscope sensors like we saw in the ASL notebook. Our aim was to embed this in a wearable device, a more comfortable device, not like a glove like where it's not an add-on, but like a wristband or our normal smartwatches. Next one. Yeah, so that's it. Dheeraj, can you continue?
Yeah. So basically, we had to use an Arduino sensor, which has the both the gyroscope sensor and the accelerometer sensor. At the time of doing the project, we don't have the Arduino sensor. We What we did is use the sensors in the mobile and designed an app to record the data. So this is the interface of the app. It records the acceleration points of XYZ and gyroscope points of XYZ. We just had to give the gesture name and it records for the particular gesture and saves in a file, a CSV file. In total, we have done 8 gestures. For each gesture, we have recorded 60 times. For each time, we get 600 points, including the gesture name, 601 points. So this is the structure of data, which we used for visualization purpose. The actual save data is different from what it is here. This data we just done modifications in the recorded data, so it will be more easier for visualization purpose. This is the visualization part. We have done the visualization, so any anomalies to identify any anomalies like outliers and anything. We have found few and we removed using some code. Uh, Later, the data was ready for feeding. Before feeding into the data, was categorical data, which has categorical value, what string values, the down to up, forward. The class labels are in strings, so we just used one hot encoding to convert it to numerical data. This is the example of how the class labels got converted, and this is how it looks. See, and this is the structure of the neural network. What we used a uh, sequential model, neural network model. And At present, the data has 600 points. I mean, including the label, it has 601 points, and just excluding the label, there are only 600 points. That will be the input layer. And we have added four hidden layers. The first one has the 16 dense neurons with activation ReLU, and 8 dense neurons with activation ReLU, and 4 dense neurons with activation ReLU, and 8 dense neurons with activation softmax. And after having the resultant, we take the maximum of it. We get the maximum. What value we get as the maximum, when we map it to the corresponding gesture, we get the output. So after designing the model and after testing and training, we got the accuracy of 95.8 on test data, and along with a loss of 0.31. Uh, and after training, testing, and validation, we have saved the model using the H5. It's a Keras model, so we used a H5 dot extension, and later using the deep sea compiler we have, as a keras model is active as one of the onyx model, the deep sea compiler accepts it. So we just compile the model using the deep sea compiler, and we got the resultant code in the cpp, which we later fed into the, we actually didn't fed into the Arduino mode. We just made a, again, virtual device like thing, virtual output. We have just done that, and this is the structure of the deep sea. Okay, and now the use cases and all. Ayisha will continue.
Yeah, so we have 8 gestures here, and we wrote a separate logic kind, POC kind of stuff to implement home automation. And the next. These are the 8 gestures which we mapped. The first two we have appliances as fan and light, and the next one is like a toggle switch between on and off. And next we have increase decrease, which would apply to the fan appliance. And increase instance count and decrease instance count is to move between instances of the appliance, like from fan 1 to fan 2 or back from fan 2 to fan 1. And next is when you tell the, I mean, next is to indicate that you're done with this appliance and move on to another appliance. So for example, when you start off, it'll have, when you'll perform a gesture that says select light, and then you'll choose an instance which says light 1 or light 2 by using the instance count increase, left to right or right to left. And once you choose your instance, you can perform an operation. If a particular operation doesn't apply to that appliance, suppose you can't increase the speed or decrease the speed for a light appliance, so the model will reject that and say, the logic will reject that and say invalid gesture. And similarly, once you're done with light, you can say next and move on to a fan appliance, and so on and so forth. A demo is there in our notebook. Please check it out. And next one. Yeah, other use cases we saw ASL, and the another one can be appliance specific. This is home automation as a whole. The other can be an appliance specific. Another one can also be gaming, where you can control the protagonist's actions through our gestures. Yeah, so that's it. Um, Thank you for this project opportunity. Thank you.
Thank you for the project opportunity. Thanks
Thank
a
you
lot.
very much, Dheeraj and Ayisha. That was great. So moving on to our next group.
Um,
We-
Gunjan, do we have time? Can I?
yeah, sure.
Okay. So guys, you forgot to introduce yourself. By the way, great work, wonderful applications, and good persistence. I would love to see your notebook. I don't know. I'll ask these guys, Arnab and Gunjan. But good work. And so on the mobile applications, you said you collected the data set using your phones.
Yeah,
Yes, sir.
Okay, and where did you find the app to collect those?
I
We
wrote
designed
it.
it, sir.
Yeah.
Okay,
Ayisha did.
cool. And so if you did that, would it be difficult to take the model, deep sea model you have, and compile it on Arduino? It's the same compiler that you can take it, right? So we can give you the binary. All your cell phones are ARM cell phones. They have ARM A series processors and Mali GPU, right? So if we give you a binary, it would be easy to port on and create another application with the binary on the cell phone.
Yeah, we'll do that, sir. I mean, how does that differ from the Arduino device and an ARM device? Like,
So Arduino is M series of processors. They're low-end processors. Your cell phone is also an ARM processor. Both of these are from the same company. Now the difference is that A series is a high performance, M series is a low power, and they are two different things. But DeepC does compile for both of these. So if you were to take this binary, design a UI with the recognizing all 6 gestures that you've designed, you can go and show it off that the underlying model is a deep learning model, right? And this would be a minor modification of the um, same app that you have developed.
Yeah, understood, sir.
So if you need help on the compilation, maybe Arnab and Gunjan can help you out and give you the model, and you can easily embed that onto the cell phone. Good luck.
Thank you, sir. Thank you.
Looking forward to the paper and rest of the stuff. Very good. Impressive. Thank you.
Yeah, yes, sir. We have submitted that to Gunjan.
Thank you, Rohit, Dheeraj, and Ayisha.